It's a pleasure to be here this afternoon. Thanks, Joe. Thanks, Fergal, and thanks to Wise and the rest of the group for the opportunity to speak today. By way of telling us a little story, you heard a little bit about I did some policy work and I did then some work in carbon markets. And my co-founder, who is a fellow named Abe Haspel, also worked in government, and that's how I got to know him a long time ago when we were doing the climate stuff. He retired in 2010 from the Department of Energy in the United States as a Deputy Assistant Secretary of the department. And he called me up and said, you know, we haven't done anything. We haven't really done anything in our lives. You know, what's tangible out there that we can say we did? We did a lot of policy. You created carbon credits, all that good stuff, but let's see if we can find something to do together. So that's how we started in this last 8 years of an endeavor which has become Cogen Energy Systems. In that regard, I had some time to work in the nice parts of the world in the Caribbean and realized there was a real problem down there. Energy prices really high, no place to put waste, and no real technologies to really deal with it. And so we thought, what can we find in the national labs in the United States that might make a difference? And that's when we came across the Idaho National Lab and our Chief Technology Officer, who was at the time working on a project to create nanoparticles out of aluminum. And so this technology that we have drawn upon comes from that origin. And it basically now is taking carbon and turning it into valuable products for energy. So I'd like, though, today to talk a little bit about scale and the scale of the technologies and why we think that this is a unique time to enter into an untapped market that just hasn't been served and we think will be a major market in the future. So we see that globally there's an untapped market for small-scale solutions or for small-scale waste producers that are just not being served by today's thermal waste-to-energy technologies, anaerobic digestion aside. But farmers, hospitals, industrial parks, condominiums, cruise ships, resorts, mining operations, remote communities, islands, all of these don't have enough waste to be able to attract the investment in large-scale, economically viable technologies to convert it, because up till now, the economics haven't been available to be able to crack that nut. So if you look at this slide, it basically shows a garbage truck. We deal in the world of half a garbage truck, 4 tons a day. And so this is your average truck that's running around around the community. And basically, if you look at that market and you say, okay, who has that kinds of waste, that amount of waste that they want to get rid of, how do you get rid of it? Well, you guys are all in that business. You know you've got to pick it up, you've got to move it around, you've got to take it to distribution sites, you've got to then take it, sort it, put it into landfills, do whatever it is. Our view of the world is one in which let's process it as close to where you produce it as possible. Let's see a world in which we have a condominium of 20 stories or 30 stories, and people take their garbage, put it down in the chute, but instead of being trucked away, we have a processing system in the basement small enough that will power the electrical power plug-ins for all their vehicles in the parking lot. That's a world in which things change. It's also a world, we believe, that is one that really will allow you to convert carbon into the resource that it is really, that it can be, the waste in a carbon into what it can be. And up to now, thermal technology conversion, thermal conversion technology hasn't been able to come to that scale. So what we envisage is a world in which any organization or any community or any business would have the capability of converting their waste on site no matter how small or how remote, we feel that we can provide a solution that will, or not just us, but there will be others, we expect, that will help move into that space, that will turn local waste into clean, sustainable energy. And in our world, as in yours, carbon-based waste is a valuable resource. So let me introduce the HelioStorm Gasifier, which is the technology that we've been working on in Idaho Falls for the last 5 years. We believe this will help rewrite the rules of the game. We process waste at 5 to 10 times the heat of our competitors. We vaporize carbon and virtually everything else in the waste stream. The result is one single pass through the gasifier and consistently clean synthesis gas that needs little or no further cleaning before being converted into valuable energy products. So we are currently working on a project for the US Navy in which we basically put the waste in the top and we bring it through the syngas out to directly into the electrical generator with one stop of scrubbing out any kind of chlorine or sulfur that might have crept in. But aside from that, it's straight in and it's usable at that point. And on a per ton basis, that unit using processing 4 tons a day will produce 800 kilowatt hours per ton, or in a day, 24-hour day, 3.2 megawatt hours of power surplus after we've powered the machine itself. All with no harmful byproducts or emissions, and so we feel that we're standing on the verge of a 20, 30-year vista where there is going to be a ton of unserved markets that are going to be opened up that just weren't there before. So first, to be clear, I want to make 2 points. One is we're talking gasification. We're not talking incineration, so that's clear. And I think that yesterday Umberto and Franco gave a very good overview of that. And secondly, it used to be when I was in my old jobs, I would come to speak at these kind of conferences and say, well, I'm from Ottawa, I'm here to help. Today, I come to you and say, well, I'm from Ottawa, I'm not Plasco. So, I'll tell you why. It's a very different technology. I feel that over the last couple of years, that's all I've been doing is saying, well, why aren't you guys, isn't that Plasco? No, it's not Plasco. So anyway, for those of you in Canada will know, or at least in Ontario will know the story on that. What's new about us is that we do ionic gasification. We run at temperatures 2 times greater than the sun, the surface of the sun, and at these temperatures, molecules are vaporized into charged ions. We directly immerse the waste into the hottest parts of the plasma zone inside our reactor. The plasma zone is 9 inches in diameter by 36 inches high. So if you think of traditional plasma arcs, which are the cutting arcs you see in torches, you're looking at something maybe that is about ½ an inch or so, where you're getting at temperatures of up to 20,000 degrees Celsius. We create a zone 36 inches high by 9 inches in diameter through which the waste falls and is vaporized. Our tests have shown that we're creating surplus energy from the system at a rate per ton of waste that exceeds the outputs of much larger systems, and therefore the economics start to work. Will they work everywhere? We recently had a call from a potential client in Arkansas, and so all things were going well, and I said, well, what's your electricity price? Well, 5 cents a kilowatt hour. Well, 5 cents a kilowatt hour is pretty hard to compete with when you're dealing with that. So some of the North American markets with low prices of oil and low prices of gas are going to be difficult, but certainly in other parts of the world, we see a real opportunity. And it's going to be a little bit like cell phones were to landlines, that back when cell phones were first introduced, everybody was kind of quiet and not really, pretty much invested in heavy infrastructure. But the early adopters were the African nations and Asia, whereby all of a sudden they said, no, let's just go to cell phones. Why would we bother with landlines? Well, we feel that with this technology, this opens that door for a technology like this to become the cell phones to waste of the future. So let's take a look at why we're different from Plasco and from other thermal other ones. Most thermal gasification technologies rely on indirect heating, but using various heating sources, some of which can be very expensive to do, others of which basically can only get temperatures up to a certain level. If you look at this, some rules of thumb apply. The lower the temperature that you're processing it at, and you guys, many of you will know this very well, that the more contaminants need to be scrubbed from the syngas stream, thus costing energy at every stage. As I mentioned, we go through one pass and we have clean syngas. Carbon vaporizes at temperatures of 3,500 degrees Celsius. At 5,000 degrees Celsius, most all atoms are gaining or losing electrons. So you're getting a highly charged field inside of the gasifier. Coupled with the cascading design of what goes on in the gasifier, which is our secret sauce, if you wish, from our inventor, we actually are very energy efficient. To start it up, we have a draw of about 200 amps to begin the process of establishing the plasma field, and we start up within minutes. And we can shut down within a minute, which also makes it attractive for those folks who are looking for intermittent processing and not 24/7 processing, although it can do 24/7 processing of waste. At this stage that we know of, to get over that 5,000 degrees Celsius, there are no commercially available. There are some on research desks and that are coming, but there's no commercial available technology out there at this stage. Let me give you a quick look. The gasifier, or the diagram in the middle, which is the more red one with the various ports, is a scheme of what the HelioStorm gasifier looks like. 3 modules with a module for a slag at the bottom. The plasma fills the entire internal volume of the vessel, and the size of this is about the size of a 45-gallon oil drum. The size of the gasifier, along with its power supplies, it'll fit in 100 square feet. So it's small, it's compact, it's designed for use in either in small applications or elsewhere. Now, the one thing that we've done in this, and I heard over dinner last night, and I've heard from others as well, is that, well, you guys are just another one of these technologies that are coming along, and it's not going to work. And we recognize that from the point of view of having had a lot of time in government circles and also in private sector circles to realize we're not going to come forward with something that's not going to have some independently verified results. So one of the things that we've taken into this is to have these results verified, and through partnerships with the Idaho National Lab, all of the results that we see here have been independently verified by them, and to the point where they've said to us they were surprised at the results. So we've processed a number of things: woody biomass feedstock with particle size distributions, bio-oil from pyrolysis, animal feed, and simulated municipal solid waste, all with pretty consistent results and very clean syngas. No long-chain hydrocarbons whatsoever in any of those, in any of that material. So no dioxins, no furans, none of that. So we're trying to bring this thing forward, and believe me, I would like to see this come forward faster, but it's one of those things, it does take time. And you guys all know in the research field and the others that it does take time. But we want to be sure when we stand up in front of an audience that we can say, yeah, we can stand by these results. And we're fortunate to have some partners in the U.S. lab systems to be able to testify to that. So I'm just going to go quickly through the next few slides and try and wrap this up. When we first started, I said we thought waste to electricity in the Caribbean. Sounded like a great spot, no problems, let's go there. And then we realized once we started working on this, we realized we had a technology, a gasification technology, that could be very valuable in many different applications with various feedstocks, because it is feedstock agnostic. It does produce clean syngas. That can be converted into electricity. It can be converted into liquid fuels or other valuable chemicals. And it can be part of a microgrid. And in fact, we've been working with the National Renewable Energy Lab in Colorado to integrate it with solar and wind in one of their microgrids. So at that point in the company's evolution and our story, we decided to pivot and become a gasifier company only. So what we realized is that there are many, many, many potential partners out there who have problems to solve, who see the potential for this, and then can take it from there. And so we're not smart enough and we're not young enough to be able to figure out all of these. So what we're going to do is work with partners over the next number of years to bring these solutions to, we don't even know what the problems might be, but we feel that it'll help in that area. Some of the untapped markets are here all around the world. We've been getting interest over the last 3 years in dealing with very serious inquiries, have signed MOUs, NDAs, everything from all various parts of the world. There is a demand, and the one thing that they're saying to us is, wow, you know, this is great. How come you guys weren't around earlier? We've been looking for this for a long time. So it's been consistent from that point of view. We've also had some acknowledged innovation from our major project that we're working on now, which is the U.S. Navy. And we expect by 2020 to have a full system up and operating in a yet-to-be-determined naval base. As I mentioned, we're also part of the U.S. Department of Energy's NREL and INL programs and working with them in partnership. And they are some of our biggest supporters, a couple of quotes from the lab directors. A very quick picture of what the technology looks like. This is the Navy unit. This will do 3-4 tons a day. This is the gasifier here. It's control panels. This is looking down into the actual gasifier, the plasma field that's created. And this will give you an idea of size for something that will produce 4 tons or process 4 tons a day. It can be scaled up and made redundant and address issues of redundancy just by adding more gasifiers to the same larger front end and the same larger back end. We've had our R&D unit operational since mid-2016. As you saw the results, we run numerous gasification test results on a number of different materials. The second unit that we've built is undergoing shakedown tests now in Idaho Falls, and that will be deployed into the U.S. Navy in next year or so. We feel we have a unique value proposition that our capital costs per kilowatt hour are actually less than or no more than large-scale thermal gasification projects. It's economically feasible at small scale, no harmful emissions, on-site processing, and in target markets, which are primarily not in Canada and the United States mainland part. It's mainly in remote parts of these countries and other parts of the world where electricity prices are a little higher. We feel that we can do significantly lower than commercial retail rates. So our target regions then, and the verticals that we're looking at, We feel that this is a very large new market. Current waste-to-energy market in the world is $30 billion, and that's the large scale. We feel that over the next 30 to 50 years, you're going to see the small scale equal that as people move towards a world in which you're going to be processing your waste locally, and you're not moving it to landfills, you're not trucking it around. It'll be done locally and in a whole different way. It's the cell phone of the future for waste. Thank you.
Good morning, everyone. Let's see, and forward here. Thank you, Fergal, and to the conference organizers for inviting me to participate in the conference. I was not aware of this conference, so I was pleasantly surprised by the presentations that we saw yesterday and today. I've learned a ton just in the day and a half already. Hope I'll be able to contribute something of value too. I think I'll be the non-technical portion of the conference. I didn't realize the presentations were as technical, although that's very needed. And I hope this conference grows, in fact, because the information and the conversation that you're having is pretty critical. As Fergal said, a part of my history or career was spent helping to create or develop a design framework called Cradle to Cradle, which Bill McDonough, an architect, and Michael Rongard, a chemist, have worked on for most of their career. The consultancy spun off this nonprofit called GreenBlue Institute because we spent, in the early years of sustainability, there was just a ton of education that we had to do in the business community to get them to understand what the value of sustainability was for innovation to their business before they could even appreciate the value of the services that we were trying to provide to them on the design side. So in terms of, there's a lot of discussion yesterday, and one of the speakers was kind of cautioning everyone to not have sort of unquestioning loyalty or adherence to any one of these frameworks, whether it's the circular economy or sustainable materials management. He threw EPR in the mix too. Really, all these frameworks are accretions over time since deep ecology in the 1970s. So sometimes they're called something different, and they become the new shiny thing, and everybody gets interested in it again. And I don't really care what they call it, as long as people tune in and start to do something. And it seems like we have some momentum now that we didn't have. So I thank the circular economy folks for kind of refreshing the conversation. So for us, our philosophical framework is kind of an amalgam of Cradle to Cradle and the sustainable materials management, which I think is a philosophy. We have a different definition of sustainable materials management than the OECD or the EPA definition. It's not undergirded so much by using carbon as sort of the index for judging the intelligence or utility of a system. It's a useful tool, but it's not the final decision. So what we do use, we have 3 principles that inform our work for SMM. And Bill used to say that design is a signal of intention, and you can tell by intentions what a value system is. So this is what motivated us to sort of put our philosophy into 3 principles. And the first one is material sourcing. And what that means is understanding the origin of the materials that you're using to make products. And hopefully that is with the prospect of identifying, if not reducing, social or environmental impacts that are associated with the extraction or agricultural cultivation of raw materials that are then flowing through the economy. By material health, what we mean is it's also important to be mindful of the quality of materials that are flowing through the system, right? And it's not just the performance or functional requirements, but what's the nature of the actual molecules. So if you're going to address toxicity in the system, you have to also have tools in place to understand what you're introducing into the system and what impacts that will have. And our goal there is, whether we're talking about a system level or an individual company's production process, is to develop strategies that will ensure that all of the inputs and outputs of the system are as safe for human health and the environment as possible. Then the last principle is material value, which we've been talking about a lot at this conference. And the goal there is to design products that retain as much of the embedded value of the materials as possible after each service life is completed, so those can become feedstocks for future products. So that's our definition of SMM. So frameworks don't exist in a vacuum. There's a larger tool set that's needed in order to make a framework effective. Some of these are obvious. We call them enablers or levers. Some people call them drivers. Technology, we've been talking about the role of technology in this conference. That's very important. Also, policy and financial instruments are important enablers in a system. These are things that either promote or constrain the ability of the system to manage materials more sustainably. I would also add new business models and even shifts in culture or the behavior of consumers. To give you, so it's not so abstract, to give you some idea, when we talk about technology, seeing some pretty amazing development or progress in how we collect and manipulate data. So whether it's cloud-based computing or mobile sources for having immediate access to that data, seeing some pretty massive depositories or repositories of data and interesting analytics that are being written to harness the practical application of that data. Blockchain has changed the security of data and enhanced that for transactions. Track and trace software has also been very useful for data transparency and getting more insight into production systems. Another example would be in the transition from a fossil-based to a bio-based economy. We're seeing that there's creation of new renewable materials as well as bio-based feedstocks that are allowing us to have different pathways for creating chemicals, fuels, and materials. And that's a very exciting prospect. Carbon sequestration, same thing. We're seeing amazing technologies and methods for sequestering carbon, if not converting carbon dioxide also into useful end products, such as chemicals and materials. I'll spend a little time talking about material recovery technologies for the project that I worked on. And then for policy, I think Canadians understand this tool a lot better than Americans do because so far we've been sort of allergic to doing anything intelligent on the policy side. So I won't spend any time on that. So I think any discussion about how to manage materials more sustainably has to start with some recognition or discussion about system constraints. So I just wanted to say a couple of words about that. A robust recycling infrastructure has basically 5 elements to it that will create stability in the system, and stability is important for reducing risk and creating predictability, which is what encourages investment. And in this diagram that we've created, and in our view, this is nothing new, but we put end markets at the top, and I've heard a couple of speakers talk about this too. This is what rationalizes the utility of the whole system. If you don't have healthy end markets, and all the material that processing isn't meeting the needs of those end markets, then it shouldn't be a surprise that it's a low-value system and it's hard to maintain it, which is what we're experiencing in the States. We lack a national coherent policy to create a dependable recycling infrastructure. So really, we rely on progressive entrepreneurs who want to innovate because they see the economic and environmental potential in creating a more effective infrastructure. And we also rely on a handful of states that also have the same philosophy. But it ends up being that it's very fragmented. So it doesn't do much. If you've got a state that has a program that's working very well, they have limited markets, possibly if all the states surrounding them are not operating as efficiently. Another persistent constraint in the system is the inability to achieve an equilibrium between the quantity of materials that are needed on the input side of the system, as well as the quality of the outputs that are capable of meeting the needs and the performance requirements of end markets. So economic profit is really based on balancing both of those, and if either one of them get out of sync, economic profit starts to leak out of the system pretty quickly. So opportunities for intervention. We've had some really good presentations talking about that. There are several opportunities within the circular economy, and they exist at multiple levels. Some of them are much less, or much more low-tech in nature than some of the transformative technologies that we talked about today. But we have a lot of opportunities in the first three orbits that you see before we even get to recycling. And it's a little odd, at least in the United States in the 90s and to about mid-2000s, universities were doing great research on design for disassembly, design for recycling, examining the economics and the systems that could do that profitably. For some reason, that has diminished with other priorities. But we could obviously be doing a lot more there. But for this conference, we're talking about recycling, so I will stay on that topic. One thing I wanted to note here is when we talk about recycling, most of the time it means synthetic materials, and it's also, most of the focus is on packaging materials. And in the last 5 years or so, we've seen the need to include organics into that equation, given that I think they're about 23% of what is put in landfills, and landfills are the third largest contributor to methane emissions in the United States. So that's good that we've brought them under the umbrella of the circular economy, but in terms of the total pie of materials that are available, those two are very small segments. And I learned a new term today, 5 minutes, thank you, that we need to create systems that we can bring many more materials into the system. One of the problems is the limitations of mechanical recycling. It's using mechanical recycling techniques, it's hard to match the quality with the quantity that I talked about earlier. So I examined chemical recycling. We've heard examples that it's a wide spectrum of processes of transformation, all the way from monomers and oligomers to chemical intermediates to fuels. The research that I did in 2017 was to look at technologies that support the processing of polyester materials, and I had a particular emphasis on polyester-based textiles, and worked within 5 industry sectors to try to gather data to define how much of that waste there is, characterize the type of waste it was, and some of the economics. You can go to this URL. I don't have time to talk extensively about the research. I'm trying to bring in a larger audience in this conversation, so you will see that the publication is very conversational in tone. written more for a lay audience than a technical audience, because we need to bring a more diverse set of stakeholders into this discussion if we're really going to have the impact that we're seeking to have. I am going to have to plow through. You will see in the report, I included 3 examples of companies that are depolymerizing PET, and sometimes there are technological differences. They're all using solvents to break the bonds and get them back to monomers. And what differentiates them is usually the business model for what they do with those monomers. In the case of Loop, this is a Canadian company, in fact. They have a pilot facility in Montreal. They have formed partnerships with resin manufacturers who then take those purified monomers and create recycled resins to create Loop-branded resins. And this has been attractive to companies like Pepsi and Coke and other beverage and food companies that want to close the loop on the materials that they're generating from the sale of their products. There is a European company that put a twist on that where they use microwaves in order to increase the throughput of the system. So if the loop process takes about 3 or 4 hours to produce a batch of PET, this company claims that they get that down to 15 minutes by using microwaves. Their business model is, I think, an intelligent one, that they envision small mobile platforms that are a highly distributed network where the waste is. And if you're going to ship something around, you're shipping a value-added product to a resin manufacturer or a reprocessor. Carbios is an example of they don't use solvents, they use enzymes and processes in nature to break the bonds of PET and recover monomers. Warren again is a very interesting example of a company that I wanted to include examples that were not as transformative, didn't go back to the monomers, but were disillusioned. This company is targeting textiles in particular. And when you look at PET, most PET textiles are blends. So cotton poly, cotton nylon. So looking that was the available feedstock, they use solvents to produce PET resin. So you can think about it as sort of a deep cleaning or a hyper purification of the resin. And they also produce a cellulosic pulp that can be regenerated into new fiber and yarns. What I think is really interesting about chemical recycling is in that equilibrium that I talked about earlier. Chemical recycling really has the ability to fundamentally change the game and the economics, I think, in that it can take low-quality inputs that would be a real challenge for a mechanical recycling system and convert those into high-quality outputs. And the denominator is always the challenge of getting enough quantity of materials in so you can have economies of scale. So it's not a total solution. There are still design considerations and purity considerations. The gentleman from Agilix pointed out that their system is not constrained about technically processing high levels of contamination, but it's a matter of yield. And if you put too much junk through the system or non-product through the system, the economics go south pretty quickly, and it doesn't become a profitable exercise, and people won't do it. So I think the main advantages of chemical recycling is there's a high tolerance for contaminants versus mechanical. It's a flexible system, which many of the presenters have talked about. There's a range of options there. It's also, because it's agnostic about the form or the application or the function of the material, it can draw on a larger pool of materials. And I tried to illustrate that by creating a map. If you go to the URL, you'll see there's an interactive map that shows polyester sources just in the eastern seaboard. And you can look by sector, you can sort by state, you can look by location. But the point here was to prove to recyclers that if you have chemical recycling technology, all of these are potential feedstocks. And I think Jay, who opened up this conference, said we need better data. That's absolutely true. Students in the room, if you can find a way to look at each of these sectors and do a better job than I was able to do in collecting information to help quantify the amount of material that is out there. That will really help attract investors who need that level of quantification in order to hedge risk and make investments in technologies like this. And then the last thing that I wanted to point out is it is cultural in the sense that if you're a designer and you allow for the concept of waste, you will have waste in the system. If you eliminate the concept of waste, it becomes a design constraint that forces you to find alternatives that are front of pipe rather than end of pipe. So we consistently have problems because we do a lot of end of pipe solutions. I like this diagram because right now I would say we're still in the middle where maybe we get one more cycle out of materials before they go to a landfill. So it's going to take very different approach to get a circular economy, and I think chemical recycling can make a significant contribution to achieving the circular economy. Thank you.
Thank you very much. And thank you to WISE and all of the sponsors for inviting us to this conference, and so we can introduce to you what we've been active in for the last number of years. As was stated, I spent 30 years of my life as a financial analyst trading U.S. municipal bonds. And I was in the business of lending municipalities money through either general obligations or various revenue bonds, and became very familiar with a lot of the issues that faced individual municipalities. And one of them, one of the things that I was exposed to was, of course, municipal solid waste, and the huge issues that surround that, both from an environmental standpoint and from an economic standpoint. Was through that process that I gained an introduction and an education into various forms of incineration, and which led 5 years ago to me being introduced to a form of advanced thermal conversion which promised a lot of blue sky. And I was captivated from an environmental and from an economic standpoint in the promise of this technology. And at that point, I did the deep dive. I am not an engineer. I am, a financial spreadsheet geek. And it required me to really gain a grasp of what have been the issues preventing this technology from really commercializing. And more importantly, if I was going to take this to Wall Street or Bay Street, what kind of external validation was necessary and could be achieved in validating these, so we could bring this technology to a more mainstream audience. What I learned through all of this is that literally there's been 5 or 6 generations of engineers who have done the deep dive on this. Billions of dollars have been spent in venture money trying to, in search of the Holy Grail. More recently, what I will say is during this 5-year period, we have looked at probably 24 different forms of advanced thermal conversion. A couple of the players we thought were credible enough where we introduced these technologies to a multilateral bank who specialized in looking for waste management solutions globally. And part of my education was, given that they were in the business a lot longer than I had been in terms of looking at solutions, that over the course of the last 5 years, they had been introduced to over 150 different companies, all claiming that they had found the Holy Grail. So that is a bit of my background. The goal is waste diversion. And one of the things that I want to highlight is the fact that we need to change the notion of waste. And in the way that I approach in the investment community and a broader range of stakeholders, is I speak in terms of these things as organic feedstocks. I no longer think of MSW and the waste that is out there as waste. I look at it as organic feedstocks. You know, they say when you change the way you look at things, the things you look at change. Well, this is a case in point. And this is what led to ultimately earlier this year having an MOU with the City of London and looking to actually have one of these demonstration facilities at the London Waste to Resources Innovation Center, which in my view, it represents one of the premier global platforms for the development and innovation of demonstration systems. Early on, this just kind of highlights the threat from an economic standpoint. This was my perspective. From a financial perspective, this was part of my world. And what was interesting, the U.S. Department of Defense is the #1 consumer of fossil fuels in the world. And there's no one that is more familiar with the problems of that than the U.S. Navy. So it's not surprising to me that Douglas, in his exploration, that the U.S. Navy is a huge proponent of this. There's nobody that understands the issues surrounding climate change better than they do. And part of the security issue, of course, is that if the seas do rise 2 meters, well, the 68 million people last year that were looking for higher ground is going to pale in comparison to the estimated 800 million people that we would have to contend with looking for higher ground. So there's definitely, from an economic and a security perspective, we have no choice but to address these issues and find a solution. From a pure economic standpoint, as Moody's pointed out last November, from a credit perspective, these are huge issues. As far as advanced thermal conversion, this represents the technology discriminators. It claims to be environmentally friendly. I can tell you that it is a non-incineration. There is no combustion in this process. They claim to have a high input to output ratio, roughly a metric ton of MSW would convert to at least 1.2 megawatts of electricity. The product is typically a biogas. And much in the way that you heard from Douglas earlier, the advanced thermal conversion systems that we've been looking at need to be scalable because we see the future as a distributable generation model. We also, the other major difference here is that other than solar and wind, is that advanced thermal conversion holds the promise, because you're producing a biogas and you can store it, it could become a sustainable baseload energy source. The most gasification or advanced thermal conversion systems claim roughly these levels of the product gas. And a lot of the entrepreneurs and inventors that I have met, are chasing this because they believe that this represents the catalyst that is needed to push us into a hydrogen future. The other thing that is promised is a very low emissions output. Most of these systems are in closed loop systems, so there's an ability for the system to kind of capture all of the various pollutants or all of the various contaminants, particulate matter in the system. And as Michael will explain to you a little bit later on in this presentation, one of the key areas, of course, is collecting data and to have independent validation of these actual emissions. When I first came back from New York and came back to Canada and to try and develop an understanding, having been gone for 30 years, I wanted to know exactly what had been going on in Canada as far as the development of biofuels and bioenergy in general. And one of my first stops was to go to BiofuelNet, which was made possible by the Federal National Centers of Excellence. And it was actually through that network where I met Michael Rich. The other thing that became clear to me that just like the Caribbean islands, as Doug said earlier, the same exact market, the same issues exist in northern Ontario and the territories, and it's virtually identical to all of the various remote communities spread across the north. What we know about the climate change going on in the north is the ice road truckers used to have 3 to 4 months of availability to get fuel in. Now they're down to 3 weeks. The Canadian taxpayer is having to put bladders into C-130s and fly diesel oil into these communities. In Ontario alone, the taxpayer is subsidizing the import of the diesel fuel to these communities to the tune of over $90 million a year. And the average cost of of electricity in these remote communities is almost $1 a kilowatt hour, and more in some cases. From a commercial standpoint and a business opportunity standpoint, I believe there's a real opportunity to get that cost, even in the remote communities, down to 40 cents. And so in terms of an alignment of interests between ReadyCan and what we're trying to do, and the government and these remote communities, we're trying to reduce the amount of dollars that have to go into these subsidies. We're trying to clean up the environment and lower the overall cost of electricity in these communities by providing them with a sustainable baseload energy source. Part of the job here is a de-risking process in terms of making these things financeable. And these are just, some of the considerations that we have to consider. And of course, the biggest issue here is technology risk. And that is why I have reached out to a gentleman like Michael Rich, who has been involved in looking at these technologies and has a wide network of colleagues, former colleagues, and professors who can help me kick the tires on whether, in fact, these technologies that we're looking at are truly valid. So with that, I'd like to turn that over to Michael. And we have an animation that we would like to go through.
While we're switching over, I owe thanks to 4 or 5 guys that have taken this partnership initiative very seriously this morning. I had car trouble in my very reliable Saab. And thank you very much, guys. You got me to a point where it isn't an obstacle. CAA is going to take me home. Thank you. We've assigned Michael now the job of being mouse master. If we can back this animation up, this is going to be highly technical, full of detail, that'll be understood by none of us, because I'm not going to explain it. We found this in our search of technologies, and it's an awfully good representation in a very generic form of what we are looking at very seriously. And we take the concept of partnership very seriously, partly because the 4th iteration of this particular technology, which is illustrated here, is being commissioned as we speak. And we are going to be given data, starting with mass energy balance, because when I approached a couple of my colleagues in a position to validate statements made about technology, they said, don't waste our time. Until you can give me the mass energy balance of the particular unit that you're looking at. And that's partly defensive for a very, very good reason. Everyone in this room knows the stories. They don't all come from Ottawa. A bad one does, but the rest are equally bad. And we are absolutely determined from a technical as well as from a financial point of view. We will not make claims on behalf of our organization and our efforts without competent validation. And Doug, thank you for setting the stage, because he seems to feel the same way, and we have somewhat similar backgrounds. One of my backgrounds has led me to being able to say what I want to say right now about what we're trying to do. It starts with a very sincere thanks to Jay, because with an MOU with the City of London, we have a platform. And it's interesting that the center is not called a demonstration center, it's called an innovation center. That changes the flavor. If we were participating in a demonstration site, we'd be selling. And at this moment, I'm not selling. I'm trying to establish a baseline for partnership, taking the resources as they come to us and analyzing them. If they become feedstock, then we have to understand what they are, their characterization. That's work for third parties. We don't have the facilities to do the complete characterization adequately. So we'll be involving ourselves with third parties, competent third parties. We'll be generating data using some technology that is protected by patent, and therefore there's some implied intellectual property. That's the black box, or in our case, the blue box. The data that we generate will be what we put in and what we get out, and we'll share that. If we had data right now and we distribute it to the people in this room, we'd get an awfully interesting response. We'd get questions. And some of those questions are questions we might not have asked ourselves. And that leads us down another path. And if my understanding from the founding of this organization, that's what you're looking for. And it's what we're looking for. This animation shows this feedstock. What on earth is it? The animation doesn't tell us, and I'm not going to tell you because I don't know. But if I give the machine something of which I know nothing, the machine could get fouled very quickly. In fact, we had one inquiry. And when we were talking to the chief engineer of the company that's doing the commissioning at the moment, he was somewhat concerned that he wasn't able to say yes, that that would be something that he would consider suitable feedstock. Now, we could blend it maybe. So again, there's opportunities. The people that we met during our time together in Northern Ontario was kind of interesting. Let me try to draw you a word picture. We're sitting in the back of a caravan, Dodge Caravan. I think it was a Grand Caravan. It was rented on the basis of the University of Guelph by two researchers, the lead researcher and his number one, just like M1 and M2. However, they were driving and we were sitting behind, and we were in Northern Ontario. And we had one of those fancy radios that seeks the nearby station. And they couldn't find a station to suit them. Now, it's worth noting that the driver was from Sri Lanka, and I think the co-driver was from Algeria. Now, we're agnostic about technology, and we're also sincerely agnostic about religion. And I quite frankly don't know which of those has which religion, but it wasn't what I follow, if I follow at all. And they couldn't find a station. And then they did. Country and Western music. I am not a fan of country and Western music. Maybe 10 minutes by some of the people that are particularly talented, but they loved it. And we drove for the next 45 minutes to an hour to our next Northern Ontario destination, listening to country and Western music. Now, if you want to get an intimate relationship with an academic, that helps. And that's what we want to do. When we take our location at London and take the innovation seriously, we will be able to divert waste. And we'll be able to do that much better because of the background that Jay has and his team has. And the data that we share will be shared willingly, I think, with the collaboration of the city. And when we do our feedstock work and our trials through the equipment, we will share data. And we would welcome, when you get the data, your very candid questions, and we'll give you the answers we're able to. And if we have to involve competent third parties, that's part of our game plan. So let me just advance this animation, because the end product in this case is electricity. Not always a conclusion or an end product that my financial friend will support. But what my friends in, it's actually Japan, are doing is they're producing hydrogen, a significant quantity of hydrogen from the syngas. And they happen to have a colleague at a local university that has solved the problem, as far as he saw it, of storage of hydrogen. Can we advance this along?
All the way?
Yep. And what he's doing is with low pressure processing, he's storing hydrogen in alloy. And the cost and the numbers that he's showing us, the data that he's sharing, it's interesting. I don't know how interesting, because it's not my field of expertise. But when I get the opportunity, I will be doing that. And what a nice way to bring a technology from Japan to Canada, along with the technology that is being illustrated here as producing electricity. Well, it can do that, and especially for diesel-dependent communities, this may be one of the solutions. I thank you very much for your attention. We look forward to sharing our data and hearing your responses. Thanks again.
My first question is to Douglas. Actually, it's a compliment. The technology which you have can solve a lot of problems, and here are those two compliments. First is the foam. Polystyrene, polypropylene, PLA, and polyethylene. They are air. Shipping the air to any place will cost us all a lot of money. So your technology is very good there. Number two, I pointed this thing even yesterday. The number of multi-layer structures, 9, 11, micro-layer, etc., are increasing. And they are good, nothing wrong. But the issue is how, when you have PETG, nylons, EVOH, PVDC, polyethylene, polypropylene in a structure, how you're going to separate them. Your technology can help a lot. My second thing is to James. We talked about some hydrogen gas here, which is a part of the syngas, and you also, Redicon. Issue is that the hydrogen is a very good source of energy in the fuel cell, and we know that technology is coming. There are stations towards California, and I think there is, if I'm not wrong, Tim Hortons is working to get some of these, even in Canada. I mean, I read it somewhere. What my compliment or the comment is that having hydrogen and the fuel cell is a very good source of energy in the remote areas, as you have mentioned, That's, so that's all. And the last point is that you were mentioning about the CO2 in the syngas. Even yesterday I mentioned that these technologies can take CO2, and I put a note about cyclic economy, where what I want to mention, I don't want to repeat here. Yesterday I mentioned that like the plants, they take CO2 and convert into energy. There are areas where big resin companies are working. If we can use the CO2 in the syngas, like we are using hydrogen for the fuel cell, in order to make ethanols or some of the hydrocarbons, that would be a truly circular economy, or what I call it cyclic economy. The reason is, and I put this thing in the LinkedIn, the reason is because we are truly doing what nature is doing. Plants are producing oxygen, we are giving them CO2, So what fossil fuels are doing to us is basically one day they will be ran out, so is coal, But if we convert whatever the CO2 in the mixed waste, we can really make use of some of those chemicals. So all the three technology which you have mentioned is a very good solution to some of the mixed waste, and for the reasons that they cannot be transported, or some of them they cannot be separated. Thank you.
Sir, I think you have just put an exclamation mark on what we were trying to convey to the group. Let me add something, because I think it's appropriate for us to put ourselves in the right position. We don't have the solution. We may have a solution for a specific inquiry. And take hydrogen as an example, and let me throw it back to feedstock. Both Michael and I are associate members of something called the Ontario Biomass Producers Cooperative. This is 50 farmers or so that have large acreages of purpose-grown crops, including switchgrass, miscanthus, willow, poplar, and they're looking to the future. The cost of that crop to be an energy crop is not appropriate for us now. But when we do our trials, we will be doing trials using their products. And they're getting now into the business that they've got 5 years, 6 years of crop experience. That will help us in the future, because the cost that we can afford to pay for it later, in the future, will make it marketable to our technology. At the moment, it is not.
Yeah. No, I certainly agree, because some of these things, yes, it will take to the future, but the biggest thing is, if we connect these technology, like what has been done by Douglas, giving the hydrogen. Now that hydrogen can be used in the fuel cell right away. We do not have to rely on any other feedstock, you know. So we have to combine some of these technology, and that's why I complimented him. These two things coming from different sources. Foam is completely different, and it's a lot to be used. I mean, everybody in this room will agree with me that there was a time 3-4 years ago when every government of every country was almost about to wipe out polystyrene foam, but there's no alternative. So if there's no alternative, maybe this is one of them. Thank you.
Thank you.
I've got a question for our panel. On June the 29th, Ontario will usher in the new Ford administration. If you had a wish or an ask for the new administration, what would that be?
That's easy. We've all talked during the last day and a half about education. Mostly we're thinking of educating our younger people to be more informed. Talk to them. They're already informed. The people who aren't informed are the people who make and enforce regulations. Thank you. Let me share something else with you. We go looking for partnerships. We go looking for people that we can talk to and have a conversation. Establish a dialogue, mutual respect, mutual appreciation, or whatever. And one of our targets are the colleges in Ontario. Believe it or not, a college called us. Now, we have an MOU with the City of London. This particular college has two and was asked by another one, what's wrong with us? So they're working with 3 municipalities on the renewable energy platform, combined heat and power. And they've already spent, very wisely, a significant amount of money. And they want to talk to us. Well, imagine the charm that, or the feeling we have when we get a call from a secondary or post-secondary education institution. That's what we want. And if we can help them achieve what they have in mind with their MOUs, with their municipalities, I know London will be collaborative and we'll be delighted. So the government has to be encouraged. When the lead person at this college made a presentation to one of the municipalities, he was speaking in a vacuum. The council of that municipality had no idea what he was talking about, and he was talking very simple terms about combined heat and power on a renewable platform. And so those people have to be educated, or what we're trying to do will fall on deaf ears. So educate up.
Well, from the perspective of those of us involved in needing a market for our materials and our products at the end, I think what I would like to see him do is not fulfill his promises that he's made. 10% or 10 cents lower on gasoline, scrapping cap and trade, getting rid of incentives for green technologies through that. All are elements that are not going to help some of the areas that we're looking to do here. You know, it's a different approach. But if he is going to get rid of those, let's see what he's going to put in place to allow the fostering of this. Education is one thing, but there are some hard economics that will probably result in many of these technologies moving to other parts of the world first, as opposed to here in Ontario.
And that's the impact that you see in terms of the cap and trade?
Well, in terms of the cap and trade, in terms of the promises to lower the prices on gasoline and fuels and the like, it's depending on how it goes, but it seems to me to be a step backward.
Marco?
Thank you very much for the presentations and information. As you may know now, me being here for 2 days, I'm from New York City, so I have to, say my thoughts. You know, Russ, you know me and Abe, and I really commend the efforts that are going on. You show data, very important. The only comment that I really need to make, and you know, I just need to say this from a perspective that we face in the United States. And what I'm hearing here is that there's some issues in Canada with, you know, policy and so on. Same issues in the United States, probably multiplied by 10. But the point is that it cannot be confusing. And, you know, we spoke yesterday about recovery versus recycle versus collected, and it causes problems. Now, from what I face on the thermal conversion side of things, is there are organizations out there that want to disparage anything related to thermal anything. And some of the maybe messages that I think I heard from some of you is a comparison against other technologies, and I'll be very specific: combustion, incineration, waste to energy. I get it. But what I can say is, of course, you have to position the different technologies, and they are very different. And I've worked with Cogen, and I know they definitely have a niche. So there has to be that comparison made to make it understandable, but it needs to be, in my mind, very carefully done, because if it looks like it is a better than, and we are not incineration and this type of thing, from my perspective in the United States, organizations like Gaia wrap that all up into disguised incineration, disguised thermal, and so on and so forth. And it confuses the message, and it actually hinders progress. And this is the point. So again, like I said, maybe this morning, that, you know, I think everyone's really doing a great job because we're pushing in the right direction. The key is that we don't muddle messages, because as you rightly pointed out, if the policymakers can't be educated and they get more confused, they'll do nothing, even less than what they're doing now. Anyway, but thank you for your efforts.
No, thank you for your comment.
that's a very good comment.
I have something I was going to say, and I chose not to. I'm sitting at the end of this table. I was at a conference about 5 years ago, maybe 6 or 7. I'm not quite accurately recalling the location. But a friend of mine was in this position. And he, unlike I, was an expert in gasification. And a fellow up there had made statements about a technology that he had. And Doug, you didn't do this.
Thank you.
The person who did introduced a new concept: close coupled gasification. And the reason he was doing that was the fault of the US. They were giving federal money in support of gasification technology development. And this person had been listening and had been talking to some of his US colleagues. So he decided to go to market in Canada, flogging something that he called close coupled gasification. If I'm not mistaken, that's what happens in a fireplace. And the fellow in this position was a very highly regarded and respected academic scientist and a good friend of mine. And he managed to walk away from that responsibility with a question like yours, because he said, how come he said that and you said what you said? And he managed to skate out of that without insulting the colleague here, but making it very clear. We have to be very specific in our descriptive language. And sometimes we're not, because it's so easy to be sloppy. Thank you.
One more question.
So
Michael.
just going back to your question on what we would ask for the Ford government, I think any processing, for any processing to evolve and for the local market to evolve, whether it's waste to energy or plastics, you need incentives. And especially on the waste to energy front, you look at Europe where tipping fees are 100 to 150 euro a ton. And here we're shipping potentially to the US for $15 a ton. It's just outrageous. So taking that comparison to the Ford government and saying, give us a break. We want to drive industry, we want to drive diversion. We have an opportunity here, but I don't see it working without much higher landfill tipping fees. I think that's your biggest competition.
Excellent. Well, please join me in thanking our panelists for some great presentations. Thank you.